All right. 10 a.m. Victoria, if you can give me a thumbs up in the chat or a comment to let me know that you can see me and hear me. Good morning, Vancouver.
Morning.
Week 2, day 1. I'm doing well. How are you? That's supposed to be my question for you.
Sometimes it's good
to reciprocate. Yes, exactly. Here, awesome. Thank you, Benjamin and Wilson. Fantastic. Perfect. Okay. Any thoughts on week 1? It was fun. Are you excited to get going on week 2?
Yeah.
Fantastic. Okay. For Victoria, the comment was that you might have to get to the end of the program and to kind of understand how it all just kind of comes together. Because right now we're just throwing things at you, right? And we're going to continue that this week. If you feel like your bucket is full, we're just going to keep adding stuff to that bucket, right? Awesome. So I hope you're excited. Could I get a volunteer or two to help with the Victoria Slack channel? Awesome. Thank you so much. Just in case I miss it, I do have it open beside me, but sometimes I just get into things and then I totally forget. And Victoria, please poke and don't hesitate to ask questions, comment, anything like that. I want to make sure that you feel supported in Victoria. Cool. So today we are going to talk about TDD with Mocha and Chai. You did some reading this weekend, so Mocha and Chai should not be weird words for you. But you I think you did some assignments this weekend involving Mocha and Chai, and you played with NPM a little bit. So we're going to talk about a bunch of different stuff in this lecture and kind of wrap it all up. So I like to start with, I haven't had an official lecture with you. I just had the dev workflow lecture, which is more like a slideshow presentation than anything else. So this is how my lectures actually go, is I usually start with a list of to-dos. This gives us some accountability. Afterwards, we can come back and we can look at the to-dos and we can say, yes, we touched on all the important points. As well as it helps to keep me on track. Because if there's an interesting question or something and we get too far adrift, this will help pull me back. Yes? Yes. Uh-huh. Right, and I can understand that. So for Victoria, the question was, you might have noticed about week 1, day 2, I did not upload a video link. So the question was, is that video available? Can I get my hands on it? And why did you mess up that badly on our first lecture? So let's work our way backwards. Okay, 1, that video is not available. The reason is because someone left the stream on the previous day. I won't point any fingers at anyone. And so it ended up streaming for 26.5 hours continuously, which is beyond the 2.5 hour limit that we have for uploading to YouTube. So YouTube just threw the video away. So unfortunately, we don't have that one. But we do have, if you go into Compass, I really don't need this one open anymore. Where's my Chrome? If you go into Compass, I think I showed you on that day, but you have access to all of the previous lectures that we've ever had, going back 5 years. So that was my first time giving that lecture, so you won't get a history of it. But if you go into the dev workflow here. Oh, well, thank you. Yeah, unfortunately, all you'll have is the memory of that time that we shared together. But if you look back at any one of these that has, it's the same kind of content. We work from the same slides. And it'll give you a chance to meet some lecturers that you haven't met yet. Or some people who don't actually work here anymore if you scroll down far enough. All right. So, cool. Yes. So did that answer all your questions about that lecture? Awesome. Any other things coming up? Trains are indeed a nightmare in Vancouver. That's why I walked to work this morning. So, okay, back to today. Mocha and Chai and this weird TDD thing. So we're going to practice some unit testing. practicing test-driven development, which is where the TDD acronym comes in. And to do that, we're going to utilize Mocha and Chai. And we'll talk more about what Mocha and Chai actually are and how we're going to use them to help make our code better. And then finally, we are going to touch on module.exports and the require syntax for how we actually get things out of a file and into another file in the Node environment. So, why don't we get started with this pesky test-driven development? Test-driven. How's the font size for the back? Can everybody see that? Awesome. Okay, so what is test-driven development? I don't expect you've heard this before, but it falls into the category of N-driven development, where N could be test. It could be something that you might have heard is behavior. Have you heard of BDD? Behavior-driven development. Later on, when we get into React Week, we will practice component-driven development, which is where we make all of the pieces of our application in isolation, and then we put them all together. So you'll build up a component library, and then you'll put everything together to finish off the UI. There are some other ones. One of my favorite ones is resume-driven development. This is when the needs of the project are not forefront. It's your personal needs as a developer. So what's going to look really good on your resume? It's when you tell your boss, I know the API works great, but what if we just rewrote it with serverless? What do you think? Because that's a big buzzword right now, serverless. Or maybe we need everything on the blockchain. Can we just migrate to the blockchain? So I like resume-driven development. And then did KV talk to you about error-driven development? Awesome. So I don't have to drop that one on you. So we have a bunch of different paradigms. And what do they all have in common? They are all our attempt at thinking before we code, coming up with some kind of plan before our fingers ever touch the keyboard and we start typing in code. So these are just, you can choose one, you can choose none, you can choose a mixture of all of them to help you out. So we are going to focus on test-driven development. In particular, unit testing. We touch on testing at several different points throughout the curriculum. This is your first exposure to it. We'll come back in week 8 and week 10, so look forward to those. It's kind of like the sequels. But there are a bunch of different ways that we can test code today, and for the next couple of weeks, we're going to focus on just unit testing. And unit testing means testing the smallest possible pieces of your code. So in essence, it boils down to a single function. And so what we're going to do is we're going to have a function that takes parameters and returns an expected return value, and then we can test against that. We can run the function, we can feed those parameters into it, and then we could say, did the output give us what we expected? That's the whole thing about unit testing. It is the easiest form of testing, which is lucky for us. And this is not about the end user. Something about, you often hear TDD and BDD kind of thrown around, test-driven development and behavior-driven development. They are extremely similar, and you probably wouldn't be able to tell from looking at the testing suite whether they followed a TDD or a BDD mindset. But test-driven development is for us as the developer. It has nothing to do with the end user. It's about our knowledge and satisfaction that we have written quality code. If we write good tests, we can sleep at night knowing that our code isn't going to suddenly crash or something bad's going to happen, right? Or we write some new code and we know it didn't break any of the old code because our testing suite is still passing. Okay? Behavior-driven development looks at your application or your program from the user's perspective. Like, how would a user utilize your app? What buttons would they click on in your user interface? What kind of commands might they type into the terminal? That kind of thing. Cool. We are absolutely going to demonstrate this if this doesn't make a ton of sense right now. But essentially, that's it. We just want to break our code down into small, reusable pieces that we can test easily. So we practice something called the red, green refactor. And yes, if you're wondering, it has nothing to do with duct tape. Thank you. Every day, there's like one student in each cohort who remembers who Red Green is. Awesome. Yes, he's the old guy. He's the old guy who used to sing. Yeah, exactly. Steve Smith. Canadian icon. Yes, but yeah. So, red. Here, I'll just differentiate this so we're not obsessed with duct tape. Red means your tests are failing. And we're going to see that. It's very similar to error-driven development. Is you start it up in the console and then all of a sudden you see this error. Except in our case, it's going to be that our tests are failing. So we write tests against our code before we ever code. Green, we write the minimum amount of code to make our tests pass. And this is really good. It really helps us stay on track because often you can start adding in extra functionality and things like that that are not actually part of your requirements. So we get to write out the requirements of our code first before we set off. So they're very similar to the to-dos. They keep us on that straight and narrow so that we don't spend too much time and effort figuring out other things. And finally, then we have refactor. And I think this is the best part about testing your code is you can, everyone's familiar with refactoring at this point? Okay. So the fact that you have a testing suite in place and that everything's coming up green means that you can fearlessly just start changing your code. And you know that if your tests start failing, you did something wrong. Whereas, have you gotten to the point where you had working code and then you were like, oh, I'm just going to refactor this or change this, and now it's broken? Or it's not quite working in the way that you expected? This is how testing really helps us out because we can fearlessly just refactor a whole bunch of code, and if all of our tests still pass, everything's great. So why would we use something like an automated testing suite? Mocha and Chai. So where do they come in? Is you've already done a bunch of testing. Your testing involved console.logging the result, right? You wrote a function and then you console log to see, is it doing what I actually think it's doing? You also practiced console.assert, right? Whereas if whatever your assertion is in here, if this doesn't pass, then you console log something out, right? So we have already been writing assertions, and let's just double check because our version of assertion is exactly what dictionary.com's version of assertion is. Zoom in, please. Why are you not zooming in? Okay, we'll do it the old-fashioned way. There we go. Assertion, a confident and forceful statement of fact or belief. So we are going to make assertions about the code that we write. We're going to say, this function, given these parameters, will return this result. And if it doesn't, our test is going to fail. So let's take a look at Mocha. I have no idea why my Zoom isn't working. No, I don't want to look that up in the dictionary. Thank you. Mocha. Did anybody visit the docs for Mocha? You really have to start zooming now. Why are you not zooming? Did anybody take a look at the documentation for Mocha? Because I know that you ran some stuff. You did? Little tiny bit. Awesome. So, I guess this kind of segues into what is Node and NPM. So you're probably aware that Node is how we run JavaScript on the server, right? It's only been around since 2009, so just over 10 years now. And in a nutshell, what happened was we had all these various competing ways of creating servers. We've got Java servers. We've got Python servers with Django. We've got PHP, if anybody remembers the LAMP or the WAMP stack, if anybody's familiar with that. But we didn't have the ability to write JavaScript on the server side. And this was annoying to full stack devs and teams because you would need different languages on the back end and for the front end, right? So you would need PHP experts, Python experts, awesome, posting the Red Green Show in the Slack channel. That's fantastic. So you'd have to have these people with different specialties. You'd have to know either multiple languages or you'd have to have multiple developers to work on the same stack. So the owners of Chrome, Google, decided to pull their JavaScript interpreter called the V8 engine out of the browser and package it up into an application that we could use to create web servers. And then that gives us the ability to write JavaScript on the front end and the back end. So now we just need one dev can handle the whole thing. It's all the same language all through the stack. Okay. So that leads us to packages. Packages or modules, as we check out npm. There we go. Build amazing things. So we needed to have some way to pull in other people's code into our projects, right? Packages like Mocha and Chai, and next week you'll use Express to create simple web servers. But there's hundreds of thousands of packages out there. They go back and forth between packages and modules. You'll notice, did you have to run npm install at all to install some packages? It created a node modules folder for you, right? But yet we call them packages, so we just use those interchangeably. It simply means a bunch of someone else's code that we're going to bring into our project to utilize to make our project easier, right? It means that we can write shorter lines of code because we brought in some library that's got 100,000 lines of code in it. So npm actually doesn't stand for the Node Package Manager. It actually is not an acronym at all. It means nothing. So on their website, they have this random thing that just runs through a bunch of user submitted npm acronyms. So now playing Mario, and then it gets stuck. You only get to do about 5 or 6, and then it just sits there. And then it redirects you to their GitHub for some reason. Okay, so that's kind of Node in a nutshell. I invite you to look more into it, to look at the history of it and things like that. But that's about all you need to know, like surface level. npm is a package manager. And so what that means is it's like a online package repository. All these things live on GitHub. We can search for various different packages on here, as well as when we install packages. If we say that we now have a dependency on Mocha, that's essentially what we're saying when we do npm install Mocha. We're saying our package, our software depends on this other software package, right? Now you can imagine that those software packages that we depend on then have dependencies of their own. And those packages all have dependencies as well. So a package manager, when we say npm install Mocha, it says, okay, I'll install Mocha, and then I'll install all of Mocha's dependencies, and then I'll recursively look into all of their dependencies and install all of those. And so when we look in our node modules later, we'll see that if you didn't already, you'll see that you have something around 100 packages get installed just to install Mocha. And this is kind of the way that the web is built. We don't reinvent the wheel at all. We grab disparate packages, slam them together, and then we sell them as our new product, right? If you've heard of the saying, I can see further because I stand on the shoulders of giants, that's exactly what the tech industry is. Someone else did all of the work so that we can add on our little layer on top and then just repackage it as something different. Okay? So npm, by the way, npm is not the only package manager. There's also one called Yarn. And I imagine there's other ones as well. We focus on npm throughout this course, so you'll only hear about npm. So npmjs.com is kind of like the Amazon of, and not like Rainforest Amazon, like Amazon.com, of your node packages. Like we can type in anything that we want here. We can look for Mocha. Hey, that's great. And then we'll actually get taken to the npm page for Mocha. And we can see that it's got a bunch of links here. This looks very, very similar to probably their GitHub repo. I imagine this is just the README from the repo. If we go there, we'll see, scroll down, scroll. There we go, scroll. Yes, so what we see here is, on this side of the screen, is usually just taken directly from the README, from their GitHub. But we can see a bunch of other interesting things here. We can see their homepage we can link to. We can get a direct access to the repository. We can see the last time the package was published. We can, does anyone go on to Amazon or eBay and just buy the first thing? Or do you look at the reviews? You look at the ratings and stuff like that. You look at other people's comments to see if this thing's going to work for you, right? How's the sizing on that shirt? Does the watch work underwater? You know, stuff like that. You're looking at how does this affect me, right? So we can look at number of weekly downloads. That looks pretty impressive. 3.2 million is a lot of weekly downloads. Over here. There we go. For some reason, my Zoom's not working. 3.2 million is an awful lot. So we can trust this package because other developers have already figured out where all the bugs are and submitted them to the producers of this package, the publishers. And so we can assume that this code is relatively error-free. If you actually want to find out how many errors are in it, you can follow through to the GitHub repo. And we can go up to the top and we can actually look at the number of, there we go, open issues. So this one has 275 open issues, 2,171 closed issues. So we can look through and we can see, do any of these affect us? Sometimes when you're picking up packages, you'll find things that directly affect you. Like it'll say, oh, that package doesn't work with this other library you're using or something like that. And you'll find issues right in here. We can also look at the pull requests, which is how many people have tried to get their code merged into this package. So they're trying to contribute code. Let's jump back here for a second. So the open source ecosystem around Node's perfect mate. I like that. The open source ecosystem around Node and the hundreds of thousands of packages that have been published is the largest open source project that humanity has ever created. And it continues to grow every single day. And it's going to grow by about 20 packages today. Because later on this afternoon, you're actually going to publish your low tide to NPM. You're actually going to publish it on there so that if somebody wanted to pull your code down, they could and include it in their projects. Cool. So we can look through here. Any questions about like NPM or Node or packages in general? Anything at all? Victoria is still doing good? Anything? Cool. Awesome. So why don't we figure out what we want to write our tests for? So I'm going to go into the prep work. Does everybody remember the katas? Awesome. Does anybody have a favorite? Oh, now my Zoom is working. Does everybody have a favorite kata? Sorry? Square code? Where was that? Oh, down here, the square code. Is anybody else? We have like, sorry? The queen threat. I want to try to get one that is fairly simple that we could write some tests for. Not that we can't solve the queen threat, but I want to make sure that we understand testing. That's kind of more so the approach rather than just solving one of these things. So sorry? The percent encoded string? Okay. We also have repeating numbers, and we also have the case maker. So let's look at percent encoded string. So the way that TDD works is we have to decide before we start what our expected code is going to do. We almost write from the perspective of we've already written the code. Now how would we test it? So at this point, we come up with things like function names, expected output, things like that. This is where we have a bunch of control over this code. So let's see what we're supposed to do here. Take a look at the following URL, specifically the last part. So we've got the %20 here. This URL will perform a Google search for the term Lighthouse Labs. Notice that when the string Lighthouse Labs is a part of URL, it's replaced with %20. So essentially, we just want to remove all of the %20s. What if we look at repeating numbers? How about case maker to start off with? We might come back to that other one. Does that work for everybody? I think case maker is a little bit more, we can just jump right in. Normally, we do something like we just write a simple calculator, and then we can say like 2 plus 2, we expect it to output 4. But I think that math gets used a lot in programming examples when it doesn't necessarily have that much to do with programming. And math is kind of scary, and testing is kind of scary, and new things are kind of scary. So if I can remove one of those scary things, so we'll just do some string manipulation for right now. Okay, case maker. We will receive a normal string of words separated with spaces as the input. Our job is to convert these strings into camel case strings. Awesome. So then we have some example inputs, like we should be able to console log camel case, this is a string, becomes this is a string in camel case, right? Did everybody work through this one in the caddis? Sorry, I can. There we go. Okay. So this is an example of how we would test it without a framework. We would just be console logging, right? And then here's our example outputs. So this feeds us perfectly for writing our specifications or our tests for this software. So before we have the ability to write, where's my terminal? Just going to do this in a separate screen. Cohort lectures. Everybody knows about the tab autocomplete, right? Does everybody know about the tab autocomplete? Okay, cool. Awesome, there we go. So ideally, so if we look at this, all I have is my README in there. I don't even have it set up as a Git package yet. So that's the first thing that I want to do, is I want to initialize my Git, right? So that I can share this with you later. So there we go. I got my Git initialized. We see that we have .git here. We kind of harp on Git a bit throughout the course. Like we keep coming back to it. And it's because Git is one of the skills that you absolutely need day one when you go on the job. It's expected that you know how version control works. So it's one of those things that we will keep coming back to. Other things you can continue to learn. When we learn about promises this Thursday, you might not understand on Thursday. You might not understand 3 weeks from Thursday. You might not understand 3 months from Thursday, but at some point in the future, you'll understand what a promise is. What we really need you to get, because day one, you're going to be they're just going to say, okay, go. And if you go to them and say, oh, I don't know how to push code, that's going to be a red flag for any employer. Okay. So, feel free to jump in with any questions. Now, I know that I need Mocha and Chai. I need to include 2 packages. So from your reading on the weekend, what do I need to do before I can start doing npm install and then the name of my package? npm init. Exactly. We need to initialize our current directory as an actual npm package. So I'm going to clear the screen so that we can do this at the top. So when you run npm init, it gives you a bunch of question answers that you can run through to fill out your package.json. You might have also seen it with -y, and -y simply means, yeah, I'll take all the defaults. Just generate my package.json so I can start installing, so I can start running code right now. But we're going to work through this npm init for right now. This utility will walk through creating the package.json file. Cool. So we take a look at what is our package name. By default, it will be the name of the directory that you're in. If you wanted to call this like Andy's new cool app, something like that, this is the name that your package will be registered as. Okay, so I'm fine with January 6th, week 2, day 1. That sounds good. Version. You've obviously seen versionings before, so we might have like 1.1.2 or something like that. So yes, Kevin. It does not. So the question for Victoria is, does npm allow for duplicated names? It does not. So keep that in mind when you try to publish your package today and it fails. Exactly. And you might even have to go beyond low tide your name if you don't have a very unique name. Because we've had thousands of students, at the very least hundreds of students who have published their low tides. So the very first person who got low tide, whoever that was months and months ago, good job. Everybody else has to be like Andy's low tide Andy, stuff like that. All the packages have to be unique, because imagine you ran npm install Mocha and it said, which Mocha? I don't know. So that actually became, if anybody heard about the I think it was 2 years ago now, there was a massive npm outage, broke the internet. Did anybody hear about that with LeftPad? So when we talk about dependencies on dependencies, it's just like in real life. If you depend on someone or someone depends on you, if that dependency is broken, then bad stuff happens. So what happened was, if we have time, yes, exactly, Wilson, LeftPad. So what happened was, because you can only have packages, like one package of that name, a developer had contributed a package to NPM that had an awesome name. And what happened was a business later on said, we want that name. NPM forced this guy to give up that package name and give it to us because that's our business name. We want people that associate, I can't remember what the package was called. And they said, so NPM went to this guy and said, okay, we need you to change the name of your package because this business has paid us some money and we want that. And he said, no, that's not how open source works. If you're going to treat me like this, I'm going to pull all my code off the internet. And that's what he did. He unpublished all of his packages, including the infamous left pad. And all left pad did was pad like zeros or spaces or things onto the left-hand side of your string, whatever you're doing. So you might want 001 to show up. So it left padded 2 zeros onto the end. That's all it did. It was like 6 lines of code. But because all of these packages depended on it and packages depended on those packages, it broke the internet when they pulled left pad. 100,000 more websites went down because all of their JavaScript stopped working. So I don't know what that has to do with versioning, but there you go. So be careful about the dependencies you pull in. Cool. So version 1.0.0, that sounds fine. Description. This is a great place to put lecture notes and example app for week 2, day 1. Entry point. So you're familiar with npm start at this point? Have you had to run npm start on anything? Yes? Oh, the test. Awesome. So it's pretty typical that whenever you, because of the way we use JavaScript and we include files and require things and stuff like that, you will generally have an entry point, a single start jumping off point. This might be your server file. This might be like server.js, something like that. So whatever you want to run npm start or whatever you want users of your code, this would be the start file. Since we're not actually going to consume it like that, we don't really care. We'll just take the default. Test command. We'll come back to this, but this would be a place where you would type in your test command. As we'll see, it's going to be Mocha, but we can just leave this blank for right now. Git repository. Here's a good one. So we're going to go to GitHub. I'm going to create a brand new repository. January 06, week 2, day 1. Week 2, day 1, lecture. There we go. Public or private. I usually make everything public, especially if I want to share it with someone. And don't ever check this box or either of these boxes. Okay? Just pretend that this doesn't happen. It's not a good idea to ever have GitHub making changes to your code, adding new files and things like that. You want your devs to be in charge of making changes to your code. Okay, so don't initialize, don't set it up with a git ignore. We'll do all that manually. Okay, and then we hit create repo. Awesome. Has everybody seen this screen before? So what we want is we want this one. Doesn't matter, HTTPS, SSH, either one will get you there. We all use SSH because 1, you set it up during the prep course, right? And 2, you don't have to enter your username and password every single time. You just connect with SSH and you're just pushing and pulling code, right? So we're going to grab that and we're going to plug it into here. So there's my GitHub repo that's associated with this package I'm building. Keywords, well, let's see, we'll add TDD, Mocha, Chai. The one I usually add is fun. You know, these would be things that people would be searching for your code. So if you wanted people to find it on NPM, put in some keywords. It's kind of like search engine optimization in that way. So you're free to describe your package, the author. I'll usually include my email address in there. And then license. This is you saying, how can other people utilize my code? Is it going to be an ISC license? Is it going to be the MIT license? I invite you to look up these various different licenses about what other people are allowed to do with your code, what you're giving them permission to do. Can they use it in a nonprofit project? Can they use it in a for-profit project? This is where you would specify what is your license. There we go. And then it gives us an output of what our package.json file is going to look like. We can see that we got name, version. You can see how this was all just populated from those questions that they asked. There's our Git repo there that I specified. Here's what happens when you don't specify a test at all. We just get error, no test specified. And then we have our keywords, TDD, Mocha, chai, fun. Everything's in there. Awesome. And then it gives you a chance to say yes or no. I'll just say yes. Cool. So if I clear this and we run ls-la, we now see that we have a package.json file here. And I can see that in my code editor. So feel free to edit this package.json. It's controlled by you. You can go in and you can change anything you want. If you want to set up a new test script, as we're going to be doing in a little while, if you want to add a new test script, let's say we wanted to do something like remove the node modules, then we'd have this run rm-rf node_modules. And now we could do npm run remove node modules, and it will just run this script for us. It'll just run this command in the command line. Oh, undo. There we go. Any questions about package.json? Are we good? Awesome. Anything for Victoria? Nope, still good. Cool. So, what are Mocha and Chai? Mocha is a testing framework. So it actually gives us the ability to run automated code. This is actually going to be a command that we're going to type in. We're not going to be like, you know how you would usually do node, whatever, index.js? We're not actually going to do node, we're going to do Mocha. And it's actually an application that we're going to run from the command line. So Mocha is our testing framework, and then Chai is an assertion library. And so Chai gives us the ability, if we look at the Chai docs, do I have Chai open anywhere? I do not. Let's just do it here. npm Chai. There we go. So Chai is a BDD, behavior-driven development, or TDD, test-driven development, assertion library for Node and the browser that can be delightfully paired with any JavaScript testing framework. So there we go. We can even see which browsers it works in. We can see what is Chai. Chai is an assertion library similar to Node's built-in assert. So Node itself, assert. Node actually has its own assertion library built in. But this is the full extent of the Node assertion library. Assert.fail, assert.equal, assert.ok, assert.rejects. These are all of our different functionalities. Whereas if we look at Chai, where would we go? chai.js.com. Let's check out the actual Chai website for the docs. Guide is going to be the API. There we go. If we look at the assert for Chai, there are this many asserts. I don't know if you can make out how big my my scroll bar is there on the side, but this is how many different assertions it adds. So this is why we bring in something like Chai instead of using Node's built-in assertion library. It just gives us a whole bunch more not same deep members and then the arguments that come in. So we're going to use a bunch of the different ones here to test our code today. Everybody keeping up? Is this still good? Okay, great. How are we doing for time? 10:40. Awesome. So I want to pull in, we have our package.json set up. So I want to pull in Mocha and Chai. So I could do npm install Mocha. We actually want to give this a special flag because Mocha and Chai will be built for around our testing, but you don't include testing code in your production application. So Mocha and Chai will actually be saved as dev dependencies, not project dependencies. And there's a difference there in that dev dependencies aren't loaded up during the production build. So if you deploy your application, it will skip your dev dependencies because they are development dependencies. We only needed them while we were developing. We ran all of our tests while we're developing something. Okay, so we're going to throw this flag in. You might see some old code that does this for regular packages. Have you seen anybody that still uses this flag? -- save. It's because when packages were installed previously, if you just did npm install Mocha, it would install it globally. So you would have had to put in -- save to add it to your package.json. Now this happens automatically for us. So let's say we don't know how to install a package. How do we find out? Docs. Documentation. It's all there. Let's go down to installation. That sounds like fun. Okay, we have a couple different options here. npm install -- global Mocha and npm install -- save dev Mocha. Can anybody guess at what the difference between these two commands is? Global is exactly that. You can access it anywhere. So we'd be installing it globally on our system, so any directory, anywhere, we can type in Mocha and it knows what it is. That's right, the whole file system. In the case of Vagrant, it'll just be the VM. In the case of your system, it would be your entire MacBook or whatever. So otherwise, we have the ability to add it just as a development dependency for our particular project. So any thoughts as to which one would be better one way or the other? We install it globally. We never have to install it again for any future packages, or we install it very package specific just in each project that requires it. Any thoughts on that? About which one would be better or worse in different situations? So one of the suggestions for Victoria was that I had just mentioned that we want to have dev dependencies so that it doesn't actually get loaded up with our production application. But we would still need, whether it's global or not, it still won't get loaded up into your dependencies. But that is an excellent point about, let's say we want to deploy it, or I want to share my code with you. If I have installed Mocha globally, then I can run Mocha and everything works. But if you pull down my code and you don't have it installed locally or globally, then your code's not going to work at all. So it's usually better practice to add it as a dev dependency. That way, whoever pulls your code down and runs npm install gets all of the packages they need, not the ones that you just felt like adding to the project, right? You want to make sure that your code is always going to work on your coworkers, on your friends, on your employers' computers. So my suggestion would be to save dev. Okay, yes. So the question was, is how long until your computer is completely full of node modules? Luckily, there's only a handful that we ever need to install globally like this that are useful across multiple projects. But we can test this out. So if I kill this and I write Mocha, I don't have Mocha installed globally on this computer. So we are going to install it locally. So I'm going to grab this and I'm going to run Command V. There we go. npm install save dev Mocha. We could chain on, not express, we could chain on Chai. We could chain on Moment.js. You can continue to add on packages. You don't have to npm install for each individual package. You could also manually add them to your package.json file. We don't actually have a dependencies here, but we could create our own dependencies, manually add packages to it, and then when we run npm install, we get all those packages. So I'm going to do this separately so that I can show you one of the aliases for npm install, which I really enjoy. So npm install -- save dev Mocha. There we go. Added 107 packages from 550 contributors. So let's clear this off. ls-la. we now have a node modules folder and a packagelock.json file. So let's take a look at those. So in our node modules, I'm just going to close these for a second. Cancel, save, close. There we go. Okay, so in our node modules folder, these are all the packages that were required just to make Mocha run. Apparently 102 of them. So they're all installed here. And if we go to Mocha, there's our Mocha, we can see that we have assets. Bin is always for binary. That means the executable. Binary it just means it's literally written in code that your computer can run. Okay. Then we have a lib, which is where their actual library would go. And then we have a changelog. We can look at their index.js. We can look at their license. What are we allowed to do with Mocha? All of this code in here, well, for the most part, will be JavaScript. So if you ever wanted to look at what goes into any of these packages, just dip into your node modules and you can read other people's code. So there's Mocha.js. Whoa, it's been minimized. You ever seen a minimized function before? Yes. Mm-hmm. Yes. Okay, so to paraphrase for Victoria, the student did a bunch of research, independent research, and came across a bunch of different things talking about like unit testing and stuff like that. And they mentioned Jest. And so the question comes down to, can I install Jest and Mocha on the same system? Essentially, yes. It won't cause a problem at all. Because we're explicitly saying we're going to invoke Mocha. We're not just saying, hey, run a test, find whatever test runner you can find. We'll actually use Jest later on in the course during React Week. Yes. Oh, why would this ever be a good idea? This is what's called minimization. So because ultimately, every website we view is a string of ones and zeros, right? We'll talk, I think Travis is giving you the TCP lecture this Wednesday. I dodged a bullet on that one. But he'll talk to you about all the different layers of the internet and how they communicate with one another. And so the bottom line, spoilers for Wednesday, is that everything goes over the wire as ones and zeros. It goes over as strings. So let's say you have this massive file and each of these, this R was an actual function name. I like that this spells rent. That's kind of funny. They probably did that on purpose. Let's say you have a function called get all users by email or something like that. Every time you're adding characters, you're making that string longer. You're making bigger file download sizes for your users. So after code is working and everything's great, you'll usually run it through a minimizer to make it as small as possible. It will take gigantic variable names and shrink them down to a single character or two. Yes? That's right. So yes, to paraphrase, you don't actually compile JavaScript the same way that you would with like C or C# or Java or something like that. We actually just dump the code onto the internet, for lack of a better term. The browser has a built-in interpreter. Yeah. The only languages that the browser knows, that the internet knows, is HTML, CSS, and JavaScript. That's it. So the question is when you open your computer, is that code executed? Whatever code you are serving to your client gets executed, might be a better way to look at it, as well as if you have any plugins. All of these are written in JavaScript. They're just DOM manipulation things. Like I have a dark reader that'll turn my screen black when I turn it on. And if you ever see, this is how you get dark mode in Compass. things like that. So all of these things are running on top of your code. If you use Boomerang for your emails, it's because JavaScript is actually running and interpreting your page for you and saying, oh, hey, you sent an email to this person last time, things like that. Cool. So that's a minimized file. So if we want to invoke this, we are actually going to need this Mocha file. And this is actually what we are going to call when we run our tests. How are we doing for time? 10:50. Awesome. So feel free to look through this. This is just JavaScript. See how much you can figure out. There's a const. Here's an if with some kind of conditional. There's another if I is greater than -1. Cool. This is just JavaScript, so feel free to look through here if you're super bored. Awesome. So we need to be able to invoke. I'm going this way. Oh, yes, I needed one more package, didn't I? I got all wrapped up. I want to look at package.json, package.json lock as well, just quickly. Package lock. There we go. Don't ever edit this file. Don't manually edit package lock.json. What this is it's saying, so if we go into our package.json, we see that we have this extra dev dependencies that got added on at the bottom, another object that got added down at the bottom, and we see that we have Mocha because I ran npm install Mocha, right? Save dev. So that's why it's under dev dependencies. And we see that it says Mocha 7.0.0, and it leads off with a little caret at the front. Can everybody see that, the caret on there? So there's various different arguments you can give here. If you just wanted to say, I want to install Mocha at 7.0.0 and just that, you would do it like this. This, which is the default when you run npm install, says, give me 7.0.0 and above. Okay? So keeping that in mind, that we might have it where we're installing, let's say I install it today, and tomorrow they release a new version of Mocha, and you run npm install tomorrow, you might get 7.1.0, right? Because I didn't specify that it had to be exactly 7. I just said at least 7, right? So what the package lock file does is it tells you exactly what versions were installed. Of this ANSI styles, whatever that package does, I got version 3.2.1 actually installed. Any match 3.1.1. So that's all your package lock does, and it's several. It usually ends up being thousands of lines of code because you need one of these for each package that gets installed. Okay, so don't manually edit it. You can, or you can choose to keep it in your repo or not. Various people go different ways. I personally don't like having it in there, but it depends on what your senior wants you to do. So we're going to do one more thing, and then we're going to check and see how we don't contribute our node modules to our Git repo. So I'm going to run npm. So npm install, we want save dev, and then we want chai. So this would be exactly the same command that I just ran, right? But npm install has a couple of different aliases that you should probably know about. There's npm I. Is everybody familiar with that one? Okay, so you can run npm I, and you can also run npm isn't_all. And that will actually work. Because what they did is there were so many developers spelling it incorrectly because you just fat finger it and you just type in isn't_all, that they just decided to alias it so isn't_all works just as well as install. So I really enjoy that. I like that. We just installed chai. We just installed chai now. So if we go into here, we see that we now have chai greater than 4.2.0 has been added as a dev dependency. Cool. So now it's almost break time. So I'll just clear this. I want to be able to push all this stuff to GitHub, so it's ready for you immediately once the lecture's done. But we can see, when I ran git status, we see that we have our node modules in there, right? And you don't want to back up your node modules for a couple of different reasons. One, because it's absolutely massive. It could be hundreds or thousands of packages with up to millions of lines of code, right? So you don't want this bogging down your GitHub repo, as well as anyone who clones your repo. You'll get used to git clone, change directory into the project, npm install. We all do it It's just the way that it goes, and it means that you get the absolute latest and greatest packages. So we don't want to commit this. So in order to avoid that, we have to introduce a git ignore file, which is how we tell Git, don't track this file, don't add it to GitHub. Okay? So now we have a .git ignore, and all we need is one line of code. Node modules. We're just telling it what to ignore. If we had more things in here, like you sometimes see, I don't know if anybody's come across it yet. Did they find a .ds store? Does anybody know what .ds store does? It is a Mac file for displaying the contents of, through Finder, of your file system. So if you had it, it's the way that Macs store your preferences. So if you had it set up as like file view, where you just see all the names of the files, it stores that preference. If you had it set up where you can see like thumbnails of all the images in a directory, it'll store that preference. And it stores it in something called .ds store, a hidden file that will show up in your directories. So if you don't want .ds store to show up, you can add that to your git ignore as well. So now when I go back here and I run git status, I see that I have a new file, .git ignore, but the node modules folder is completely gone. You see that that's not in here anymore. It wants to track package.json, package lock, the readme, and the .git ignore. So I can safely say git add everything. I always run git status, git add, git status, because it's your one last chance to visually look and say, oh, my node modules are still in there. I don't want that. If you want to unstage things, you can run git reset, and then if we run git status, we see that it's no longer staged. Okay, so if you stage something that you don't want and you're like, oh, I need to add that to my git ignore, just take git reset, it unstages everything. Yes?
So say you git add, git commit, and
yes.
before you push, could you still do the reset?
Once you have committed, if you're committed locally, you can revert that commit. But once you start pushing to GitHub, kind of the way that Git works is it's always a going forward process. So even if you undo something that you've already done, what it does is it just makes a new commit to undo your previous commit. Because that's the way version control has to work, right? You can't just go back and just start editing files and stuff like that and then saying, no, that's how it was. Git is always a going forward thing. So even undoing something is a step forward to undo the previous thing. Okay, so we're going to add everything. We're going to run git status, visually check. This all looks good. And then I'm going to git commit -m, and I'm going to call this initial commit. Or how about something better? Going for coffee commit. There we go. So if we clear this, no, I don't want to copy. Clear. And then I run git status, on branch master, nothing to commit. Git push, origin, master, and this is probably going to fail. Yes. So you'll see this. Fatal. Origin does not appear to be a Git repository. So the way that this breaks down is Git is a command, right? Push says, send my code somewhere. Origin says, this is the destination for my code. Whatever the origin is. Origin usually refers to GitHub, okay, just by convention. And then which branch am I pushing? Master branch. But if we run git remote -v, we haven't actually set up any remote repositories yet. We had the rest of that on here. This is the command that we want to run down here. Git remote add origin. So git remote add origin. So in other words, we want to add a new remote. Git remote add. We're going to name it origin because that's the convention for GitHub. And then it's going to be that GitHub at github.com, whatever destination of our repo, right? So when you run this command, and then we run git remote -v again, we see that we now have two remotes called origin. One for pulling, one for fetching code from, and one for pushing code to. Okay, they just happen to be identical. It will always create two for you because you always want the ability to push and pull, right? So now we can run git push origin master. And done. So now it's up here, and if I refresh this, we see that there's the start of our README file, And we've got our git ignore and everything in there, but you see that we don't have node modules. No node modules in there at all. Cool? Awesome. So, how are we doing in our staying on track? Scroll back up to the top. Practicing unit testing. Haven't done any of that yet. Using Mocha and Chai. Haven't done that at all. And we haven't created nor consumed modules using Node's default CommonJS syntax. We've got a lot. You guys have really gotten off track, I got to say. You got to tighten it up for next time. So we're going to take a 10-minute break, and then we're going to come back and hit all 4 of our to-dos. Awesome. All right. Split screen. There we go. Welcome back, Victoria. Please give me another thumbs up to indicate that you are the stream is back online. All right, Vancouver. Any questions come up during the break? Any deep thoughts while you're standing in line at the coffee machine? Were you wondering why the coffee machine takes a minute to brew every cup of coffee? And why we don't have more of those? I did a... Oh, Bryce found it. I wasn't sure if anybody was actually going to find that. Thank you, Bryce, for exposing that. My cohort mates put me in Slack when I was a student here. So you can still colon Andy, and it'll put me... it'll put me in there. You can add things to Slack, by the way, if you're not aware. Just scroll all the way down in the emoji list, and then it says add new emoji. It was my cohort mates. I didn't do it. I didn't do it. It wasn't me. Awesome. So, yes. Is everybody petitioning for more coffee machines? Is that what's happening right now? Everybody's like, quick note to Glenn. More coffee makers, please. Okay. So, we have 49 minutes to write some tests and make them pass. So, we're going to do this right from the beginning. So, what is our command? Now that we've installed it, and I know it took an hour, but now that we've installed Mocha, we are ready to get started. So the official getting started says install Mocha, make a directory called test. So by default, and remember that developers are really lazy, so we love defaults. Okay, so by default, Mocha will look inside of a test directory for any testing files. Okay, so and then this line of code simply says, open your favorite text editor. So this would be VS Code, it could be Sublime, could be whatever. Just open it and start writing some tests. And then let's take a look at some tests that we could write. So they're actually using the Node built-in library, because they're not saying you have to use Chai with Mocha. We are electing to use Chai. This is just the built-in assertion library. And then this is the syntax for writing our tests. We have Mocha gives us two functions that we can call. One called describe and one called it. Describe is used to group tests together. We can have as many of these blocks, these describe blocks, because you see that it opens here and then it closes down here. So all of this, this is inside of that outer describe that says describe array. So we can nest these as deeply as we want. It depends on your project, your personal way of writing tests, and what your senior tells you to do. At my last job, it was 2 levels of describe and then all of the its. That was just the senior said, this is what we're going to do, is the outer describe would be the name of the file, the inner describe will be the name of the function, and then it's all of the tests down below. And we like this because it kind of lends itself to being read really well. Like it's almost pseudocode in a way. It's like describe, and we're going to call ours, what cat are we doing? We're doing casemaker. So we'd be like describe casemaker.js, so that when the test suite runs, we can see in the console which files are we testing. Then we have another describe inside that says, I'll make this a little bigger. Every time you squint, I make the font size bigger. So you're either gonna have to move closer again. I just, there's only so big I can go. Cool. Okay, so the syntax is very simple. It takes a string. However we want to define it, we can put whatever we want inside of there. And then what is this? Starts with a C. You saw it. Andy reacts only. Awesome. Thank you, Benjamin. So what is this? What is this blue thing that I've highlighted? It's a callback. It's a function that we're passing to another function. So if KV didn't underline that you were going to see callbacks absolutely everywhere, you were going to see callbacks everywhere, pretty much every single day for the rest of boot camp. Because it's just, they solve so many different problems for us. And then if we look inside of here, we see that this describe takes a string, and then I got to disable that. There we go. And then yet another callback. And then our it also accepts a string, and then yet another callback. Okay, so you're going to see this over and over and over. We're probably not going to use this verbose function syntax. We'll just use arrow functions, which I think were introduced last Thursday, right? Okay, so this is our basic syntax. But that's not really going to work for us. Here's what we need. So if we had installed Mocha globally, we could just run Mocha. But since we haven't, we have to tell our computer where to look for Mocha. So go into our node modules folder, starting in our current directory, go into the node modules folder, go into Mocha, go into the binary, and run the Mocha binary for us. So let's copy that, and let's clear this, and we'll paste it into our terminal. So this is going to be our very first attempt at running Mocha. No test files found, test. So what this is telling us is, remember when I said that the default is a test directory, right? And we do not have a test directory yet. So I'm going to make a directory called test. And then we're going to rerun that command. Let's try Mocha again and see what error we get. Slightly different error. Remember we talked about red-green refactor? So this is our first red. It's showing up red in the console. We have to fix it. So first one said, no test files found in a directory called test. Now it's just saying there's no test files found. Okay. So I'm going to touch inside of test, and this is going to be case maker .test.js. So period, if you have any questions about this, period is a perfectly valid thing to use in a file name. So we'll often, so if our file under test is called casemaker.js, that's going to be our top level file where we write all of our functions in, all of our JavaScript, then the test file for it will be .test.js. Okay. The only thing that matters, you can put as many of these in here as you want. The only thing that matters is the very, very last one. This is what we call the file extension. So this part, the .js part, is the file extension. Everything to the left of that is the file name. Okay, so you often see things like .html, .js, and things like that. It's you only concerned about that very end, just what is the file extension. So did I actually touch this file? For some reason I feel like I didn't. Nope. Touch test / case maker. There we go. .test.js. So now if I look inside of our test directory, we now have an empty test file. Let's run Mocha again. And is anyone getting tired of ./node module /mocha /bin /mocha? That seems pretty wordy, right? Let's go into our package.json and do some things as a developer. So we have this test script here. So if I run npm run test, we get that error. No test specified. All this echo command is it's a shell command that says just print whatever that is to the console. So all the default thing is saying, yo, I don't have any, you didn't give me a test command, I've got nothing to do. So we're going to replace this with our test command. So now that we've set our test script up, we can now do npm run test. And now we see that it is actually doing the exact same thing. And just to prove that, I'm going to paste this in. And it's doing the same thing, 0 passing, 0 passing. But we finally have green, because luckily for us, 0 Mocha considers that a positive number. So we've got our very first red-green refactor going on here. So now we're finally going to get into writing our tests. We'll just close this for a second, and we'll open our test. So what was the criteria for our case maker? Well, we will receive a normal string of words separated with spaces as the input, and our job is to convert these strings into camel-cased strings. So why don't we start with the absolute most basic? We are expecting that the return value is a string, right? That's the absolute most basic thing. We're saying that when we invoke this function, the return value is going to be a string. So let's import. So we need const chai equals, actually it'll be, let's look at how chai works. So interestingly, because we run Mocha from the command line, we don't actually, see we run npm test there. We don't actually need to import Mocha into our code. We don't need to require it because we're actually running it as a Mocha program. But we do need to bring in chai. So let's go into here. This is the guide installation. There we go. npm install chai. Dev dependencies, added chai. Browser, you can bring it in with CDN, other platforms, blah, blah, blah. Let's go to assertion styles. Is it going to tell us how to install it? There we go. Var assert equals require chai dot assert. So that's what we're going to do. Const assert equals require chai dot assert. We could also have done const chai equals require chai, and then const assert equals chai dot assert, if that makes more sense. These are equivalent. What we're saying is require in the chai package, but pull off of chai the assert functionality that we need and store that into a variable called assert. Okay, we're just doing it in one line here. Do you want me to do it 2 lines for clarity for the notes? Does anybody have a preference? Is any of this confusing? Does this look fine? This is the require syntax. We're finally touching on one of those to-dos. Okay, so we're going to leave it with this one, and we're going to move on. So now we have our chai assertion library. So the first thing we want to do is we want to describe, and our file under test is going to be casemaker.js. And then we have our callback function. Everyone okay with the arrow function syntax? Agreed. Callback. Awesome. Thanks, John. Everyone good with the arrow function syntax right now? Yes. The question is do you still need these? Yes. You need to put those in because otherwise it doesn't know what this is. If you had a single argument, you could do it without round brackets. I don't recommend it. I recommend always doing this. And as this is our first real lecture together, you'll notice that my usual coding style is that I make sure I close everything when I open it. That way I don't ever forget, oh, I need a curly brace, or oh, I need a closing parens, or I'm missing something. I will open and close it and then come back and type inside. Okay? It just helps me keep on track of that, because you'll end up with a file that looks like this, and then you'll be like, no, it's a squiggly line. Is it one of these? Has anyone played this game? Yeah. Okay, so this is my way to not have to do that. Okay, so now we're inside of this describe. So let's see what our tests look like. npm run test. Still 0 passing. So far, so good. Okay. So now we have our describe block. And our very first test is going to be it should return a string. So this is our very first test. We can save this, and if we go back and run this again, we'll see casemaker.js, it should return a string, and according to Mocha, this empty test is passing, because we haven't actually put anything in there to assert. We haven't made any assumptions about what gets returned. We haven't thrown any errors, so Mocha says, test file ran, looks great. So there's our describe text, if you're wondering where that came from. This is casemaker.js. That's what I typed there. And then it should return a string, shows up from right here. Okay. So now we are going to call we're going to say result equals, I keep typing case marker for some reason. Let's assume that our function is called casemaker, and we're going to pass in a string. So lighthouse in the house, something like that. And then we're going to make our first assertion. We are going to assert, and here's where, no, I have no idea what that is. VS Code, too helpful. We're going to assert something. So in order to find out how we assert, by the way, there are 3 different assertion styles here. Can I zoom this back? Installation, getting started guide, the basics. There's somewhere in here that shows there's 3 different ways to phrase your testing, and it's all due to how you like to phrase your code, how you like to write your code, or how your senior tells you you're going to write your code. So there's assert, there's expect, and then there's should. And they all have slightly different syntax, but they all accomplish the same thing. So just for simplicity, and because we're already writing assertions, we're just going to use assert. So let's take a look at, let's go to the API for assert, and we want to find type of. There we go. Because we want to assert that the type of our return value is a string. So here's where you can say, that's a little hard to read. There we go. Assert.type of t would be a string, and then it takes a third argument of, which is fully optional, no one ever uses the third argument, which is to console log something extra. It's kind of like your console.asserts that you were writing. So we need to assert type of result is a string. So this is all we're testing. We're literally broken it down to we should get back a string when we invoke the casemaker function. So let's run this. npm run test. This is our first red. Well, our second red after getting Mocha to work. And it's telling us we got a reference error. Casemaker is not defined. So we can see here we have a red test. It's not passing. And then we're seeing that casemaker is not defined. So up here, I'm going to say const casemaker equals, and ultimately we are going to accept a parameter, but like I said, the red-green refactor says write the minimum amount of code that you need to make your test pass. So I'm going to return an empty string. And then we're going to run npm test, and our test passed. Our function returns a string. So does anybody think this is kind of dumb? Does anybody think this is not exactly ideal? That we could get around our test simply by returning an empty string. We're supposed to be turning something into camel case, right? We're supposed to be creating Lighthouse in the house as camel case. All we did was return a string. This is why you need to write good tests, right? Thorough tests that test everything. Because if you just said, if your senior says, I want at least one test, you're like, yeah, I wrote the test. I assert that it returns a string. Is it coffee time yet? So this is why we want to write good tests, because otherwise you might have a function that doesn't do what you think it does. Awesome. So there we go. So we need some more tests. What was our description here? Because I think we had some tests inside of our kata. We not? So we want to see something like this. This is a string, comes out as this is a string. So let's take that. This is going to be our next example. I like to do, if I'm saying that I'm passing in a certain type of argument or certain arguments, I'll say given this is a string, returns this is a string. Once again, callback. And now we say exactly what we said here. Const result equals casemaker pass in this is a string, and then we would assert. So now we need a different assert. We're going to do one of the simplest assert, which is assert equal. So let's take a look at this. We go down to assert. You're going to scroll down. Let's look for dot equal. So the way that dot equal works is you pass in the actual value, you pass in the expected value, and it compares the two using deep equality, so triple equals. Okay? So we're going to assert, just like you did your equal arrays, remember EQ arrays, stuff like that? You passed in the one array, you passed in the other array, and then you compared them. We're doing the exact same thing. So we're going to say assert equal result and the expected to come back. So this is a string. There we go. There's our next test. So we run clear this and run our tests. And now we got back a little more. So we have one that's passing. That's awesome. Our function is still returning a string. This is great. But we have one failing. Given this is a string, returns this is a string. And it gives us, because we made an assertion about what came back, it will show us what the expected was, which is this is a string, and the actual that came back. So we see that we expected empty string to equal this is a string. Mocha is trying to tell us this is what your test said would come back, and this is what actually came back. And you might have seen some of this in the test, in the mock test when you were running them, similar to this, because it was running a testing suite behind the scenes. Okay, so now we need to actually write some code. So let's go into this, and we're going to expect to get in a string. So how are we going to handle our case maker? We could do something like, again, if you didn't have very good tests written, we could simply return this as a string, and watch what happens now. All of our tests are passing because our function is returning a string, and it returned this is a string and satisfied that test. Everyone good? Confused? Keeping up? So we're going to need some more tests in here, right? We had some other example cases. No, I don't want to drag that. Thank you. There we go. We also had loopy lighthouse, and we had supercalifragilisticexpialidocious, right? So let's grab these two, and we'll write some quick tests for it. It'll be easy enough to just duplicate this. And this time it's going to be loopy lighthouse. So given loopy lighthouse, and here we'll see loopy lighthouse again. Then return loopy lighthouse. And we'll add our last test into here. Be careful about copy and pasting tests, because sometimes you just change the test name and you forget to change what you're actually passing to the function. So we're testing one huge long string. We'll put this into here. There we go. And then we'll put it into here. And we expect it just to come back, because the way that camel case works is it's everyone after the first. So since this is a single word, we expect it just to return that single word. Okay? Cool. So now we have a very robust testing suite. Oh, we got a bunch of failures. 2 passing, 2 failing. Given this is a string, returns loopy lighthouse. See, I didn't change everything. Loopy lighthouse will return loopy lighthouse, and given that gigantic supercalifragilisticexpialidocious, returns that. Let's try this again. npm run test. Okay. 2 passing, 2 failing. Given loopy lighthouse returns loopy lighthouse, expected this is a string to equal loopy lighthouse camel case. Same thing with, we expected this is a string to equal supercalifragilisticexpialidocious. Okay? So we now have our tests are failing, because all we're doing is just returning this. So how are we going to capitalize all of the words? What have we learned in the last week that can make this pretty easy for us? How are we doing for time? 11:34. We could say split all of the words into an array, right? We'd have multiple words. We could split them all up, lighthouse in the house, and give us an array of just those 4 strings. That'll make it easy to manipulate, right? So we'll call this word array equals str.split, and we're going to split on empty space. So far, so good? Now we want to iterate over this word array. Const word of word array. Actually, let's use, this is one instance where we can use a C-style for loop. So let I equals, but we don't want to start with the 0th, right? If we said I equals 0, I is less than word array.length, stuff like that, we would start with the first element. But in camel case, we don't actually want to capitalize the first word, do we? So we want to skip that one. So an easy way to skip it is to just say, let's start with index 1. I is less than word array.length. That's our ending condition. And then I++ every time through the loop. Okay, so now we have our current word would be word array at I, right? That's how we access that particular word every time through the loop. So let's put together a return array equals an empty array. And the first thing we're going to do is push into, stop me if anything seems weird. So essentially what we're going to do is we're going to build up a return array that has capitalized every word except for the first one. So we're just going to push that one right into there. We're going to push that first word in. And then the very last thing that we would do, I'm just going to separate this, is we're going to return array dot join with no spaces in between. Okay? So should we test our code? Because I think at least supercalifragilisticexpialidocious will pass. Awesome. Because absolutely nothing was done to this, it passes the test. But we see we now have 2 other tests failing. We expected this to equal this is a string, and we expected loopy to equal loopy lighthouse. Everybody following along? Awesome. So how do we capitalize the first letter in a word? Okay. So we'll split this out. We'll just make this super easy. So we're going to say word array at I, that's our current word, at 0 dot to uppercase. So that capitalizes our first letter. So then how do we get the rest of the word? Slice? Someone suggest slice? Let's try that. Word array at I. Tell you what, to make this easier, let's call this word. That way we can just say word at 0. All right, so we need all the rest. So we're going to slice starting at the first index, right? We want to slice from there to the end. If we're not sure, mdn string.slice on mdn. The slice method extracts a section of a string and returns it as a new string without modifying the original string. So we'd say string.slice, the beginning index, and optional, we can specify the end index. We're going to leave that blank, so it's going to start from the first index and just give us the rest of the word. Awesome. So now we have the rest. So what do we want to push into our return array? We want to push in that first character and then the rest of the string. Okay? So first will be capitalized, and we should probably actually, we'll deal with that in a second. If we have some time, we'll refactor this test because it's not ideal at this point. npm run test. Everything's working. Go on, ask a question. Somebody wants to ask a question. Otherwise, I'll assume this is so low level we can just start jumping through. Everybody completely bored with this? Everyone knows exactly what all of this code is doing? Not seeing any nodding faces, but I'm not hearing any questions. Okay. Yes.
I'm just kind of getting what's happening here now, like with like some of the like extracting arrays out of or like words out of the array and everything. Like
Yes.
it's like the word array 0 on the top function there. Like I can see that that's extracting the first word. Like what I've been struggling with is the order of how to actually write that. Like if I wanted to write something like return array dot push, and then not really sure what goes easy after that.
Oh, okay. So,
I mean, I see it now.
okay.
It's just a lot of it happening at the same time. That's all.
Right. So for Victoria, it's kind of a lot of things that you've already seen, things that you already know, but just cobbled together in perhaps a different way or a more concise way. So feel free to review this when I send the notes out. And if you want to talk to a mentor about what in particular is happening. But what came to mind while we were writing this out is we're missing a test. What if we end up giving it, where's my case maker test? Oh, I was already in it. There we go. Given, because the thing about camel case is that we want to capitalize the first letter, but we also want to lowercase all the rest of them, right? So given this is a string, we would want to get back, given this is a string, returns this is a string, right? That's what we would expect to come back from that. But our code, I have a feeling, is going to fail. So I'll grab this, copy that. So we'll say const result equals case maker, pass in this, and then we assert dot equal result. Oh, it closed on me, result. And this, oh, this is a string. Okay, so I'm going to pass in something that has random capitalization throughout, but we're expecting our code to clean it up and just return this is a string. But if we run our tests now, our first four tests, still passing. Everything's green, we're great. But we got back, this is a string with all these capitals in it, which is not what we're looking for. So how do we solve this in our code? Yes, I know it's low battery. This could be catastrophic if it doesn't last for the next 18 minutes. I might have to run and grab my charger. Think about that while I run and grab my charger. All right, anything from Victoria? Thoughts, ideas, suggestions? And juice. Hey, we're back in business. I could lecture all day now. I hope you don't have anywhere to go. Okay, what did we come up with? Oh, right here? Oh. Oh, I see. So we're going to call to lowercase, and then we're going to split it. Awesome. There were other options. Did anybody come down here and say dot to lowercase down here? You could. Oh, it would actually. You're correct. So the question is If I had passed in something like this, then I was just blindly putting that first word right in. But your solution, which this solution down here wouldn't help if we called 2 lowercase down here. But the solution that you came up with, it will break if you add spaces ahead of the first word. Ooh, we're getting even more tests to run. How much time do we have? 11:45. Awesome. Let's add a test for that. This is what you want to think about while you're writing out the test suite, is what we call edge cases, ways that someone might use your function in a way that you didn't intend. Because we have a natural tendency as devs to test the happy path. We want to test everything's working. This looks great. I typed in this is a string, all lowercase, and gave it to me back. This is a string. But we want to write robust software that takes these edge cases into account. So let's deal with that one as well. So we're happy here. This should solve everything. Let's run our tests, make sure that our test suite is passing. npm run test, 5 tests passing. Awesome. And let's add another test. This will be our, I know we could continue writing tests, but this will be our last test for right now because I want to touch on module.exports. So given this is a string, returns this is a string. Const result equals case maker. I'm going to pass in so a bunch of left padded spaces, if you will. And then we're going to have exactly the same as this. We're going to assert that we get back this is a string. So we run our test suite. We want to see that red before perhaps you've added a new test, but our code perfectly handles that. We don't need to deal with it. You always want to make sure that you get that red before we start writing new code. Cannot read property to uppercase of undefined. So it didn't actually get so far as returning anything to us. It simply tried to call. So let's see where we're calling to uppercase. Right here, clearly our first word is coming back as undefined. So we're trying to call to uppercase on something that doesn't exist. So how would we handle this? I heard somebody say it immediately. Trim. So we're going to trim the string. So what trim does is, if you haven't come across it before, is it removes the leading and the trailing spaces, right? It just goes and just gives you back the relevant characters that you want. So we're going to trim it, then we're going to call to lowercase on it, and then we're going to split it on every space that remains. This is also a great example of functional programming. How we can chain together all of our different methods on the previous return values. So string, we know it's an original string. Calling .trim on it returns a shorter string. Trims off the front and the back spaces, if any. Then we call to lowercase on it, which returns a string, just all lowercase. Then we call .split on it, which returns an array that we store in a constant called word array. And let's see if our tests now pass. There we go. So that was all we needed to do. We now have 6 tests, and we are fairly confident that we could deploy this code, that we could share this code with other people, and it's going to do what we expect and what they expect, right? We have confidence in it now. But we don't want to write our code inside of a test file, because the test is simply just for testing. We want to be able to take this case maker, and I'm going to touch something called casemaker.js. And we want to take all of this code, if I can successfully highlight it. Keep going up a little more. Up, up, up. There we go. We want all of this to come out of here. And we're going to go into CaseMaker. And we're going to paste our code into here. Awesome. So now we have a functioning CaseMaker function that we've tested thoroughly. And we've removed it to a separate file so that our application could actually use it. So how do we get it out of this file? We've got this CaseMaker function. We know that it works. We need to at least get it into this file, So how do we get it out of CaseMaker and into the test file or other files in our application? Exports. Yes. So we have access to this object called module.exports, where we can either overwrite it and just give it the name of a function. If we had, we could also do module.exports.casemaker equals casemaker. You'll see syntax like this, because how do we add a new key to an object? What must this be if we're using ... on it and it's JavaScript? It must be an object, right? So we can add new keys to an object by just saying key name equals value, right? We could also use square bracket syntax. We could say we're adding on to module.exports and we're giving it a new key and a new value to take out of this file. We could also do module.exports. It's very common that if you have multiple, let's say we had other functions in this file that we wanted to export, you could just export them as keys on the module.exports object. And if we're using ES6 shorthand, if the name of the key and the value is the same, this happens so frequently that we can omit this portion. So what this says is key equals value, their names are the same, so we don't have to write it. For, yes. Yeah. It depends. So the question is can you do that with everything? Let's say we had const name equals, I don't know why, Andy, and then I want my user object to have a name property. So now user object will have a name property of Andy. Because oh, well, you mean, so it would be the name of the variable that you're using, not the name of the value on the other side. Yeah, it's the name. As long as this name matches whatever that key would be, we have the ability to just do this. So wherever you see this, assume that it just says this until you become comfortable with that syntax. Okay, so we have all these different options for exporting it. Let's get rid of this one. Okay, so now we've got it out of this file. We've said, hey, everybody else who cares, we've written this file, this function, it's been exported, you can now import it into your work. So how do we import things into a file? We have to make a declaration, we have to set it equal to something. So we could say casemaker equals require. And now let's take a look at our folder structure. So we've written our test to be inside of the test directory, but we need to get up to this top level casemaker. So what do we need to do? ... to go up, and then we're going to grab casemaker. Awesome. So this isn't quite doing yes. Okay, so the question is how do you, let's say we exported, we had another function. What were some of the other ones that we could have stolen from the caddis? Percent encoding. So let's say we had another function called percent encoding, and we were also exporting that one from this file. How would we bring that into the other file? Well, this is not actually going to work. This, in our current situation, all of our tests are going to fail here. Let's clear this. npm run test. Casemaker's not a function, casemaker's not a function, casemaker's not a function, casemaker's not a function. Everything broke because we are exporting an object. So what we're importing is an object with a key of casemaker. So we can either say this is going to be our casemaker object, and then we need const casemaker to equal casemaker object dot casemaker. There we go. Yes. So the question is when you're importing, do you need to make the names the same? You don't. You can actually name it whatever you like. We could have called this function under test and made reference to it later. We don't have to name it exactly what was exported. It's just the convention to do that. You can only export once. No, you can actually export multiple times. It depends on how you're exporting. If we were doing this syntax here, especially if it was this syntax, you'll see this quite commonly where people do, what was the other one? It was percent something. Percent encoding. Thank you. That's how long my memory lasts, was about that long. Percent encoding equals percent encoding. And you can set up multiple ones, or like I showed you, you can do it here. They result in the exact same thing happening. Yes.
If you export once and then export again the same thing, it's basically the last time overrides the first time.
I haven't actually played with multiple, like, yes, if you defined another key of CaseMaker here, it would overwrite the previous key, just like assigning a new key, like a new property inside of an object would overwrite the previous property, right? If we only do module.exports equals whatever that was, then yes. Yeah. So what Kevin is asking about is if we did module.exports equals CaseMaker, and then we did module.exports equals something else, then only the something else would actually get exported. Okay, so let's just make sure that all of our tests are passing. Clear this, npm run test. Okay, so that is, we were able to successfully export our code from one file and import it into another file. But this is kind of gross, right? For lack of a better term. This doesn't look fantastic. We end up with this casemaker object.casemaker, stuff like that. ES6 to the rescue. So we can use something called object destructuring. And what object destructuring says is create a new variable and set it equal to this particular property from this object. So we could say pull off the casemaker property from that casemaker object that came in. So these two lines of code here to get in the casemaker object and then set casemaker equals casemaker object dot casemaker. So it puts our function into this. It does exactly the same thing in one line. This is called destructuring. I know the syntax can look a little wonky, but you will get used to this the more frequently you do it. And this is our preferred method of importing things and breaking them down. And then if we had a second one, let's say we were exporting that percent encoding, then we would also pull that off as well. And if we run our tests now, we end up with the exact same thing. We were able to successfully import CaseMaker and then run a bunch of tests against it. So I'm going to separate those two. Cool. Any questions before we revisit our to-dos? I know this was a lot to take in. There's a lot of stuff that we cover. You're going to get a chance to write a bunch of tests today against your load tide before you submit it. Any questions about Mocha syntax, chai assertions, ES6 destructuring, exporting, module.exports? Everybody good? Just overflowing with questions and waiting for mentor hour to start? Like, where is everybody? It's 11:59. I'm already in the queue. Anything like that? Okay, so let's jump back to our README and make sure that we actually did what we set out to do today. So practicing unit testing via test-driven development. Can we agree that we wrote 6 tests and we practiced some unit testing? Is everyone clear on what unit testing is? We're testing the smallest unit of our code. In our case, it's usually functions, because they take in some values and they return some known values that we can guess at. We used Mocha. We even set up our own npm test script, right? We use chai for all of our assertions, assert.equal, assert.typeof. Feel free to go through those docs and find the assertion that you need, or flag down a mentor and ask, like, how would I test this function? And then we created and consumed modules using Node's default syntax of module.exports and require. You may come across different syntax. You may come across the import syntax, which is brand new, but it's in the ES6 standard, but it's not supported by Node at this time. So we encourage you to use module.exports and require for right now. Okay, so if you see like import whatever syntax, we'll just convert that to require. Okay. Any other questions before I let you go? Good? Awesome. Victoria, good. Can I get a thumbs up before I let everybody off the hook and you can dig into Monday's Compass material? Is anybody in Victoria still watching? Is my mic on? Yes. My mic's on. How are we doing? There we go. Perfect. All right. Thank you for your time. If you have any questions, I'm here for the rest of the day. Victoria, feel free to Slack me. Thank you very much.